This tiny sheet of rubber can move using thousands of volts, and I'm trying to figure out whether it or some other technology could someday compete with electromagnetic motors. Hi, my name is Atlas. I want to find a new class of actuator to work in robotics. I have zero academic education in electrical engineering, material science, robotics, or any other discipline. I'm living on a high school diploma and a dream here. The purpose of this whole channel is going to be to document a normal, regular guy using AI to essentially find new and interesting ways to combine these different disciplines and hopefully emerge with some kind of hybrid actuator technology, something novel and efficient from my garage and home lab. Some of the most accessible starting points that offered some unusual properties and allowed for a bit of danger is actually this class of polymer called dielectric elastomers. Now, these elastomers are typically made from a soft rubber, silicone, or an acrylic, and the key principle here is that when you compress the rubber in thickness, it actually expands in area. This is something that's referred to as the Maxwell stress, or essentially the electrostatic pressure, which is just a fancy way of saying the attractive force between two electrodes, a positive and a negative. If you sandwich this elastomer between two electrodes and then induce a strong enough current or a strong enough electric field, the electrodes will compress the elastomer and cause it to expand in area. So the primary problem with this technology, one of the first things that I ran into is dielectric elastomers actually require immense voltages, so somewhere around 3,000 to 5,000 volts, really just to get started, and they require really thin films, even with these high voltages, to get a measurable field stress. So this presented a challenge right up front, especially for me specifically, who knows very little about electrical circuits, electrical engineering. I spent a solid 2 to 3 weeks just learning from scratch, testing my own circuits. ChatGPT, Grok, Gemini, they all helped tremendously with setting up layouts for my circuit diagrams, and I did end up shocking myself a few times. I built my own flyback transformer using an ETD 34 core. I got some fun sparks out of it, somewhere between probably 2 to 3 millimeters. So we're looking, maybe 1,000 to 2,000 volts with that flyback transformer technology. But it was not safe. It was sketchy and not something that I wanted to deal with. So finally I decided, I'm not an electrical engineer. I'm just going to go and, purchase a desktop supply instead of burning through all these MOSFETs and these resistors. So I ended up purchasing a high voltage supply from Alibaba, really useful for everything I'm going to do in this channel. So it was kind of a justified expense. Works great. It's about 100 watts, so I can get about 10,000 volts out of this particular model, and it demonstrates the initial motion and the initial voltages, and really this phenomenon that I'm looking for, this Maxwell stress. It demonstrates it really well. That was great. Now, the second challenge that I ran into came from finding the right materials, so the film materials. I checked Google for Elastosil, I checked for 3M VHB tape, and a bunch of other common materials that were quoted in a lot of these papers. And eventually I actually did settle on 3M VHB tape, as well as actually making my own film in-house in my oven, really, in my kitchen oven, which my wife was a huge fan of. And I was able to get some fairly decent results out of that using EcoFlex, which is a part A and a part B mixture. And I was able to get about a 1 millimeter film, fairly uniform, fairly uniform for the thickness. However, there were just too many imperfections, so it did have some very severe breakdown effects in the long term. So when I started pushing the upper limits of that power supply, I didn't really have success there. But I was able to demonstrate this with the 3M VHB tape very well. It is a lot cleaner and more efficient. As you can see in the results here, I got a pretty promising show and expansion from this. Very, very solid, promising results. And I've got to say, guys, not to toot my own horn here, but it really went a lot better than I initially expected in many regards. So, I've learned a ton about electronics, a ton about circuitry, thin film manufacturing, and plastics manufacturing. I did a deep dive on a lot of this just to try to get a better idea of the hands-on techniques that are used. It's a pretty new technology as far as the research that's going into it. It's been around for a while, but not a lot of people are playing in it. So it's really still in its infancy. So I feel really good about where we're at, and And this is just the first step in Built by Atlas, a regular guy building interesting things one question at a time in his garage. Tune in next time. We're going to look at a new exotic material that actually just arrived in the mail that I was able to purchase from a supplier out in Colorado, as well as some new iterative designs that I want to employ for the elastomer film, and some new actuator setups that I want to test. So stay tuned and subscribe, please. It would help me tremendously. This is video one, so we're kind of just getting started. Hey guys, so on a side note, if any of you are interested in what I'm currently working on with the dielectric elastomers, whether you're an engineer or just somebody tinkering in their garage, I have a lot of the technical details about what I've done, where I've gotten things, the procedures that I've used, that kind of thing. I didn't want to include all those in the video because it would be a very, very long video, and I'm really not trying to make it technical. I want it to be enjoyable to watch and enjoyable to follow along with. So if you do have any questions, feel free to leave a comment. I'm going to do my best to keep track of all of them and really give as much information as I can. So thank you.